Hello everyone, today I'm going to present my midterm paper called Bias in AI Image Generation and Mitigation Approaches. So let's start with some motivation and background. So the AI image generation technique is now thriving in many industries including entertainment design and advertising. Unlike humans, who often consciously apply bias, the existence of bias in AI model may seem surprising and mysterious at first glance. And the bias actually originated from many sources like training datasets, design choices, stereotypes, and human interference. So, what is actually a text-to-image generation model? It is a comprehensive tool that generates image given text prompt. And with the continuous development of deep learning and NLP, we now have many popular text-to-image models accessible. Some of them are commercial, and some of them are open source for or free to use. Um, uh, to summarize the categories of bias, is mainly the social bias, um, since many social stereotype bias happens in the training process and in the dataset cause the behavior of the model contains some social bias. And there are mainly two that category in the bias in image generation model. The first one is detection, and the second one is mitigation. So for a bias detection, we mainly focus on a previous work called a bias painter framework. It utilizes an image processing pipeline to access the skin tone of generated image and further convert it to landmark. And after calculations of pixels on the landmark, risk assessment is done. And when it comes to some gender assessment and age assessment, the bias painter incorporates commercial face analysis API called Face++. And unlike traditional image generation process, the bias painter creates image through cinema images and neutral prompts to reveal potential biases that may emerge during the generation process. And this trigger logistic brings more accuracy. For the mitigation part, there's mainly three stages for bias mitigation. The first one is stage before the training. One could augment the size of the dataset or use more balanced sample to decrease the bias ratio. Secondly, you could also add regularization terms during the training to avoid the model consistently generating specific facial features. The last stage is to evolve measures applied after evolve measures after the training. So this is the after training stages is main focus of this paper. So more specifically, one can improve the text prompt that is input to model to mitigate the bias in result. For example, one can get diversified results if they simply add terms like from different culture for different gender after a photo of a CEO in text prompt sent to the model. This means ethical intervention may significantly change the representation of each social or racial group in results, making the stereotype less dominated. And this approach is validated and its efficiency is examined by previous research. And in this paper, we designed two small experiments for detection and mitigation respectively. So for the experiment of the detection, we adopt a simplified version of the bias painter. So while the framework is neither implemented because of time nor utilized because it requires a paid subscription. The procedure of the bias detection in the framework is reproduced in some extent in this paper. And we use two models which support image reference in the procedure of image generation to mimic the trigger component in bias painter framework. So for the city images, we collect them from Google and in three categories. For the race category, we have black, white, and Asian people. For the gender, we have male and female. For the age, we have young, middle, and old age people. And so there are 54 total images. And for the neutral prompts, we collect from the previous work, and they are cleaner and bus driver. And the model used are stable diffusion XL and Adobe Firefly. And here you can see example. The left side is the city image, and we prompt with bus driver, and we get a sample one in stable diffusion XL. For evaluation, we calculate the following metric. So we calculate score. We record score for each image when there's a change from during the transformation from the CD image to the resulting image, and if there is a difference, we calculate score respectively. And we also have a word score and model score for each word and model. And basically, the higher the absolute value in the results, the more bias in such category and word and model. And here you can see the results. It's showing the table 1 and table 2. And in the table 1, we split records by the gender for each prompt word. For each gender, we list all the combination of race and age. And here we use some simplified category name. WY means white young person. We then classify and record all the occurrences of resulting image into different categories. We finally calculate all metrics for each model. And from the table 2, we can see that in SD XL model, the gender score has the most significant value compared to others, meaning that we are more likely to observe a change from male to female with prompt word cleaner. And we can validate this by looking more carefully the table 2. The model depicts cleaner assumed 30 times out of 81, even though the image guidance is man. And in the reverse direction, only 3 males generated out of 81 images in female. And in comparison of the two models, we would observe that Firefly have relatively low score for most metrics, and even gets score of 0 in age and risk score for prompt word bus driver. And this indicated that Firefly is more likely to produce unbiased result in similar form of image production. And some more specific analysis, even there's unlimited bias in the simplified experiment setup, since we are not using paid API to recognize the resulting image. Instead of that, we use human annotation by 3 graduate level students and my friend, and we still successfully trigger some bias in text-to-image model and gain some significant results. And some insights couldn't simply be derived from data collected and metric calculated. During the whole procedure of image generation and annotation, we see a remarkable tendency that image generation guided by Asian people will produce non-Asian as a result. Black people are produced more than other two races in both professionals. And the potential reasons could be the biased dataset with non-Asian dominated and bias from social stereotype. And for the second experiment on mitigation, first we introduced two biased prompts that is mentioned in previous work. They are housekeeper and CEO. And for the ethical prompt additions as intervention, we only add three kind of interventions, regardless of their gender, race, or age. And we generated and compared outputs with and without ethical interventions. So there are 20 images for prompt with and without interventions, and two models, totally 80 images in total. Here is an example photo of housekeeper. We have 20 images generated. And the results of experiments for both models are shown in Table 3 and Table 4, respectively. And we could observe the Figure 3 that the original run in XDXL is extremely biased, and most of the people generated image of housekeeper is Latino, young female. When improving the prompt using ethical intervention, like regardless of their gender, race, and age, we will keep getting 20 images of woman, black, and old person, respectively. Similar in generation of CEO, as the XL model will keep producing 20 middle-aged white males. When improving the prompt using ethical intervention, we will keep getting 20 images of woman, black, and old person, respectively. For result on Firefly model, it is unsurprisingly unbiased as we have in the bias detection experiment. Though not perfectly balanced, our generated result from both professions includes individuals spanning various age ranges and racial groups, with an almost equal likelihood of being male or female, and more even distribution on racial groups, age ranges, and gender appeared after applying the ethical interventions. Some analysis from the completely different results from the two models, we learned that the effectiveness of this prompt design approach differs among different models. For XDXL, the inclusive language attached on the original prompt is more like a reminder to the model. It's acting like a warning word instead of a semantic phrase. That whenever the model processes words like gender, race, and age, it will generate results about disadvantaged groups. It could sometimes be women, be old people, and be underprivileged racial group. In our case, it's black people. And the potential cause of this situation may be related to concerns about equality during the model's design. For Firefly, we could observe some mitigation on bias in distribution of generated outputs. Since the result is already objective enough, the effectiveness of the approach is not obvious. Some discussion on limitations. So the limitation is mainly on the scope of this experiment to avoid extra expense. Advanced models are not available to use, and furthermore, more comprehensive prompt design and dataset augment is required for more authentic results. And also, unavailable human annotation brings some subjectivity in the annotation. Besides that, the problematic prompt processing logistic deep-rooted in the model makes the mitigation approach not working as expected. At the end, there are some questions for you guys to discuss. and thank you for watching.